Today we're going to be learning how to find the area between two curves. So if we have our coordinate plane here and we have two functions that are like this, we can find the area beneath this top curve, this area in yellow. This is just the total area under the curve. We can do that with the normal integral. And then we can find the area under the bottom curve as well. I'll do these backwards. And if we subtract this total area from the area under the smaller curve, we get what's left in here. So now we're going to do some examples with this. We subtract the total area from the tiny area underneath the lower curve. So we have two curves here, y is equal to x squared and y is equal to 4x. And so we want to find the area between these two curves. So the first thing I generally do is I try and graph it and just kind of see if I can work out anything from here. So I know what a parabola does, and we're at the origin because it's just a normal x squared. We have this parent function here. So a parabola does something like that. And then we have this 4x, and we know that there's kind of this, we have a very steep slope because this is 4. So it's just going to be a straight line like this. And so to solve for the area in between these curves, we just subtract the two areas. So we subtract the area from this one. We take the area of this one and subtract the area of this one. So let's work that out. So the total area, let's call it A, is equal to the integral, and we want to find these bounds of integration. So we want to figure out from where these 2 points meet. So they meet at the y values, right? We want to see when these y values are the same. So that's x squared is equal to 4x. So if we can divide by x on both sides, assuming that x is not equal to 0. But if we assume x is not equal to 0, we have to think about that. And if x is 0, they're both 0. So 0 is a bound of integration. They intersect at the origin. But now we can remove 1x from both sides. So now this is just x is equal to 4. So this x value is equal to 4. So we're going to go from 0 to 4. And then we do top curve minus bottom curve. So this top curve is 4x. So we're going to say 4x. And then minus the lower curve, which is x squared. And then we're going to integrate with respect to x, so we're just going to write dx. Top minus bottom. So we're going to perform our power rule. We're going to add 1 to the exponent. So this is x to the first plus 1. And then divide by that new exponent. Add 1 to the exponent and divide by that exponent. So now we get, I'll simplify that, that's 2x squared minus x cubed over 3 from 0 to 4. 0 to 4. and I can just substitute my values in. So that's 2 times 4 squared minus 4 cubed, 4 cubed over 3. And that's it. So this one's a bit different, and I'm going to also do this one a bit differently to show you that you can do it like this. So if you have a problem that you don't want to do with respect to the x, for whatever reason, it might be a bit easier to do it in the y direction. So let's look at these. We have 3 lines here, and we're going to find the area between these curves. So we have y is equal to x squared, that's just a parabola. We have 1 over x squared, and that does something like this. And then we have y is equal to 9, which is going to be something like this. So let's try and figure out these points of intersection here. I don't want to deal with some of these random points up here in our x bounds, so we're going to do this in the y direction. So let's look at our bounds of integration in terms of y's. So we know that this is going to intersect at y equals 9 here. But when will these two curves intersect? When will this x squared and 1 over x squared graph meet? Well, if we multiply both sides by x squared here, we just have x to the fourth equals 1. Taking the fourth root of both sides, x is just equal to 1. So this is at y is equal to 1. So y is equal to, that's not 9, 1. So y is equal to 1 here. So to find the area of the curve, under the curve, we can do everything in terms of y's, and or in the y direction, meaning solve for x instead of y's. So let's go write these two things in terms of x's. So taking the square root of the first equation, we get the square root of y is equal to x. And let's see, moving the x squared over here. So like x squared, x squared, and then dividing both sides by y, and then taking the square root of both sides. The other one is 1 over the square root of y is equal to x. So now we can do our integration from on y bounds. So 1 to 9 with our other functions here. So which one is going to be the top function? Well, we have a square root function or an over the square root function. And anything above 1, which it is always going to be bigger on the square root function. So we're going to look at the square root function. So we just have the square root of y minus 1 over the square root of y. And remember, we're not integrating with respect to x here. We're doing this in the y direction. We're starting here and adding up these tiny little subtractions here in the y direction. So this is dy. So now we can do our reverse power rule here. So this y, if you want, you can think of it as y to the 1/2. And this one is just y to the minus 1/2. So let's add 1 to this exponent. So that's plus 1. So this is now y to the 3 halves. Now we have to divide by that exponent. So divide by 3 halves, or multiply by 2/3. 2/3. And then we're going to subtract, and then we're going to add 1 to this exponent, and then divide by the new exponent. So this new exponent is 1/2, positive 1/2. So dividing by 1/2 is the same thing as multiplying by 2. So this is just 2 square root y. And then we're doing this from 1 to 9. 1 to 9. All right, let's go over here and start substituting our values. 2 times 9 to the 3 halves over 3 minus 2 square root 9. And then I'm just going to take this and say subtract 2/3. 2/3 minus 2. And this is our answer. So you can do this in both the x and the y directions.